Hi everyone. In this presentation, we'll be discussing about our final project for the course CSCI-5253 Data Center Scale Computing. We built an application called Present Play, and we'll be discussing about its goal, its architectural diagram, and its working model in the upcoming slides. So myself, Varsha, and we have Adarsh and Prashant here, and we all work together in building this application. So the main goal of this project is to build a web application that will let users book sporting courts across various public sporting centers across the country. So the application has two interfaces. One is a customer interface and one is a manager interface. In the customer interface, the user can search for a code either in his current location or in a location of his choice. So he can give the location and he'll get a list of codes which is nearer to that location. And once he has a list of codes, he can select a code, view the details of that code, see the ratings and the slots available in that code. So if he wants to book a slot, he can select a slot and he can book a slot in that particular code. And not just that, he can also give ratings to that particular code. And coming to the manager's interface, the manager will have his own login page and he'll be the admin of that page. So he can add new codes, he can list all his codes, and whenever a user books a code, he'll get a notification saying that so-and-so person has booked a code. So coming to the software and the hardware components, so the front end, we've used Angular to build the front end, and in the back end, we have used a list of services. First is the RPC and API interfaces. We've used REST API for the interaction between the user and the application, and gRPC for the microservices, the inter-service communication, and this is synchronous. And for asynchronous communication, we've used message queues, where we've used Kafka for sending those notifications. And the key value store, we've used Redis for maintaining the authentication, the user session details. And for marshalling, we've used protobuf between the services. And we've used two different databases. One is a PostgreSQL and Mongo. And we maintain the users and the events data using Postgres and code data using Mongo. And we've packaged the entire service, our entire backend using Docker, and we've deployed it in Kubernetes.
Next, we'll talk about the architectural diagram of Present Play. Here we are expecting to have two types of users. One is the customer, next is the code manager. Though they both have different user interfaces, all of their requests goes through a common load balancer, and there are two receiving microservices. One is a user microservice, next is a code microservice. And in order to help us with the session management, we are using Redis. And in order to help us with figuring out and getting more information about the location, we're using an external tool called GeoFi API. And to do inter-service communication, we are using two components. And in cases where we have to use synchronous communication, we are using gRPC. And in cases where there's no need for synchronous communication, we are using Kafka. Next, we'll reach the data layer. This is where I'll talk about the third service that we have built, event service. So as the name suggests, this service stores all the events that go through the product, like which user has booked which code at what time. And as we can see here, user service and event service are using Postgres as their primary database, and code service is using NoSQLDB MongoDB, and to store all the images, it is using GCS. Next, I'll give a brief overview about our deployment process. So first, initially, in order to test about like how the application works in isolated environment, we built a Docker Compose environment of a whole product. And once we got a good handle of our deployment, we moved on to deploying the whole services on Kubernetes. And as we can see, we are running all the services on Kubernetes here. So next, we'll talk about how did we test and debug our application. In the initial phase, when we were building the application one by one, we had to do a lot of manual testing. And once we had a good chunk of code, we started writing unit tests. And once we started having preliminary versions of each application, we started building containers of each of them to see how they are acting in isolated environment. And once we had all the services ready, we started using Postman to do API testing and also some integration testing. So to talk about what were our learnings from this whole project, first and foremost, we learned the importance of having a microservice architecture. With this, we were able to parallelize all the work among the team members. Next, there were a lot of hurdles while building the applications. So we also learned the importance of how nice it is to have a proper logging application. And at the end, as the project requires, we got on-hand experience in planning, designing, building, testing, and finally deploying an application. And at the end, how a backend should interact with UI, what are changes that is required to do that. So overall, this was a very good experience. Next, we'll move on to the working demo.
So moving on to a live demonstration of our built application. This is our landing page. Here, as you could see, we have the current available sporting courts across the United States. So here we can see like what is the current rating of this, each of these one, how many slots are available, and what particular sport that sporting court serves for. So now we can use current location button to get the current location of the user, and it will accordingly sort the courts based on increasing distance from his current location. Yeah, so as you could see here, currently we are in Athens Street, so the ordering of this has been changed from the lowest increasing to the highest increasing. Then we could also search this here manually. For example, I could enter like something like 29th Street, and it will show me the list of 29th Street nearby. So if I, for example, select 29th Street, New York, then you could see the courts ordered according to that from lower to higher distances. Then I can log in as a customer and as a manager. Suppose I log in as a customer. Now I can just view the individual courts list, like what are the available, like the court information about this, what is its current rating. I can also see the available slots. As we could see, there are 4 slots available here. So I could select one of these slots and book them. So it will be marked as booked and it will be disabled so that other users can't book this slot. Further, I can see the profile information of the logged in user. Apart from this, I can also rate this court. For example, if I give it 4 stars, you could see the rating getting updated here, and I could rate it again, and so that the rating accordingly gets updated. Now I can log out and log in this time as a manager. If I log in as a manager, then he could only see the phone number and the current rating. He can't see any slots, any available slots. Further, if we go to the front page, like we could also add court for manager. So if I could enter these details quickly. So could enter these details, and I could enter some slot times here. And I could enter the sport which this particular thing serves for. For example, say basketball. Then I could add the court, and you can see it gets updated here. So now I can view this court as well. So now I could see the notification which the manager has received, and it has seen that the person Adarsh has booked this court between these. So this will occur when a particular user has booked a slot, and we get the notifications from the Kafka queue which we can view. So yeah, that's the demo of our application. Thank you.